we are going to proceed to dimensions. Okay, when we talk about dimension, we are actually talking about character of an object. For example, if you want to tell a person about a box, let's say you have a box, you want to explain this box to a blind person, let's say. You're going to tell the person that, oh, this is a box where it have a length, it has the width, it has the height. Okay, so the length, the width, and the height is actually the character of the box. Okay, so the dimension is actually the character. How much the length is, how big the width is, how big the height is of the object. So because we are talking about physical quantities, we are learning things objective way. So the way we elaborate, okay, the box here to a blind person according to these three character. So the length, the width, the height, all of them actually a kind of length. Okay, a kind of length. Isn't it? So the dimensional symbol we are going to use is actually L here. Right? Okay. Okay. For the SI units, let's say this is for time. Okay, the physical quantity is the time. The SI unit is second. The dimensional symbol, capital T, stand for time. Okay, for a length, okay, the SI unit is meter. The dimensional symbol is length, capital L, stand for length. Okay, for the mass of a physical object, the SI unit is kilogram. The dimensional symbol going to be capital M, stand for mass. Okay, so this is the dimensional symbol that we're going to use. So if you refer to area, okay, SI unit is meter square. In terms of dimensional symbol is L square. Okay, goes the same to the volume. The SI unit is meter cube. The dimensional symbol is L cube. For speed is meter per second, and the dimensional symbol meter is length L per second over T. Right? Acceleration ms negative 2. For the dimensional symbol L T negative 2. Okay. So dimensional analysis is actually a technique, okay, where you are going to use this technique to deal or to take a look, analyze on the units of the physical. Okay, when we have dimensional analysis, first thing first, we need to know that this is actually a technique, okay, a technique to do analysis on the units in simple of a physical quantities, of the things or object that we want to know or learn about. Alright, so using dimensional analysis, okay, has two purposes of it. Okay, first thing first is the first purpose to do analysis, okay, of an equation. We want to know the units of the equation. Alright, for example, we want to know the units of the formula that we used to in previous or prior knowledge from your primary school is about, let's say, delta x equivalent to v naught t plus half at square. If let's say the object starting from initial x, 0, and v0 is at rest or 0. With this condition, okay, the situation going to be x final equivalent to half at square. So from this expression, we want to know the units, okay? We want to do the analysis of an equation. What is the units, okay, of the x, let's say. So now, we are going to use the dimensional symbol, the step, okay? We are supposed to put, okay, bracket. This is a must to use a bracket. Brackets means that we are now using dimensional analysis process. Equivalent to half a t squared, bracket as well. So for this purpose, alright, okay, for the half numerical value here, okay, which is half here, has no unit. It's just a numerical value, has no unit. The one that has unit is a and t squared, as well as the x. So when you open up the bracket here, we are going to drop the half because it has no units. Remember, dimensional analysis talking about analysis on the units or the dimension of an object. So now, madam going to open up and replace the symbol with the dimensional symbol, right? So we have here, right, A is meter per second squared as our unit first, dot, okay, the T is second squared, right? Then simplify the things, meter as finish, isn't it? Only. So then finally the dimensional symbol or the unit for the x is actually length or meter. So we are now confirmed that the x has the dimension of length. Okay, so this is the first purpose on to use the dimensional analysis to analysis of an equation to, or in simple, to figure out the unit of an equation. The second purpose of using dimensional analysis is to do the analysis of a power law, right? Analysis of a power law, or in simple, this is the term that your textbook are using. In simple, we are going to use dimensional analysis to derive a proper equation. Okay, for example, we have a statement that x, okay, a statement of x is depending on a, acceleration, and time in general. So how to have the equation of that, right? So from the statement that madam said just now, the x is depending on, okay, from a paragraph of statement. Now we're going to convert it into mathematical expression. X is depending on the acceleration and, okay, the time. But how it is depending on? Is it directly proportional? Is it inversely proportional? We don't know. So we are using dimensional analysis to derive a proper equation from a statement given. Or another term used in your textbook is analysis of a power law. So for sure, okay, the A has the power, the T has the power as well, right? So let's say the power of A is power of n. The power of T is, let's say, power of m. Right? So its exponent, n are exponent that must be determined, and the symbol of directly proportional or depending on indicates its proportionality. Alright. Okay. This relationship is correct only if the dimension of the both sides are the same. Okay. Because the dimension of the left side is length, just now we know this one is length, x, right? Okay. The dimension of the right side must also be length. Okay, that is the idea. So now we are going to use the dimensional analysis technique. So, alright, here we have the dimension of the x is equivalent to a dimension of course there is a, when we convert proportionality to equivalent, must be a numerical value or constant, right? Okay, times with the a power of n times with the t power of m. Don't forget that we are now using dimensional analysis technique. So, in terms of x, when we replace it with the dimensional symbol, it's actually a length. So, it's capital L. And k is numerical value. When you convert it, open up the bracket, the k going to be dropped because it has no units. It's only a number. Alright. So you're going to have, firstly, a is m as negative 2 power of n times with t is second power of m. Do not open the bracket yet because you are still using SI unit, not the dimensional symbol yet. Okay, and then simplified, whatever you can have, m, n, okay, and s, negative 2n plus m, isn't it? So now we're going to have m is length, so L power n, and s is time power negative 2n plus m. On this side we have L, okay, but then we don't have t yet, isn't it? But as I mentioned before, whenever we give a statement is equivalent to, it must has the same unit, both sides, right? Therefore, it must be t at this side as well. It's just that the t is power 0. Anything that power 0 equivalent to 1, right? So, it's power 0 equivalent to 1. Most of the time, we won't write down it. Understood it exists and the value is 1. So, the L, okay, is power to 1. Right. Now, we are going to analyze the power law. So, means that for L, okay, the n equivalent to 1. Right. For the t, 0 equivalent to negative 2n plus m. So from here, okay, we're going to have m is equivalent to 2 times 1, which is 2. Right. So we have the value of the n and the m now. So let's refine your formula here. Right. So put it properly, finally. Alright. Your x is equivalent to the numerical value k. We don't know yet. By using dimensional analysis, we cannot have the numerical value. That is the weaknesses. Then a power n power 1, and then t power 2. Right? Or in simple, k a t squared. So if you see here, this is actually a hint of, right? It is quite here similar to this, isn't it? So actually, okay, k here is the half. But then we cannot have it by using dimension analysis. To have the half, okay, for those who are taking A level or STPM, they have another step to do to figure out the k value, which is to plot a graph. From the graph, they're going to figure out the k is half. But for our syllabus, okay, we're not going to do that. We are finished until here. So in dimension analysis, there are things or items that has no units, okay, therefore it has no value. For example, 1.25, it's just a number, it has no unit. Therefore when you put it in terms of this, okay, it will be dropped, okay. And then mathematical expression, for example, ln, log, okay, exponent, okay, those mathematical expression has no unit, okay. So it has no unit, it has no dimensional symbol, right? But then sometimes a constant which has unit, for example, Young modulus constant, shear modulus constant, has the unit, therefore it's going to have the dimensional symbol. So how about sin, cos and tangent? Sin, cos and tangent or cotangent or cosecant is actually a mathematical ratio, okay, of two sides of a triangle. So when we talk about ratio, it also has no unit finally, because the ratio cancel out each other, right? Okay, so when it has no unit, again it has no dimensional symbol. Okay, when you open up bracket, it will be dropped. Okay, remember that. So this is the two purpose of using dimension analysis. Again, first one, to analysis of an equation, or in simple, to figure out the unit or the symbol, the dimensional symbol of an item in an expression or equation. Second purpose is to do the analysis of a power law, okay, or in simple, to figure out if there is a given statement that x is depending on the acceleration and time, okay, from that statement you are going to make a proper equation by using firstly proportionality. A paragraph of statement just now is summarized into proportionality statement like this, then convert it into mathematical expression and put bracket here, meaning that you are now going to use dimensional analysis technique. Simplify anything that you can within the bracket here in SI unit. Finally, when you already simplify everything, then you're going to replace every single symbol or units with the dimensional symbol. Okay, here you don't have t initially. Actually, we do have t, but the t is power 0. Okay, and then now you're going to use analysis of a power law, where you're going to consider for L in terms of power, the n equivalent to 1. For t in terms of power, you have this equation, 0 equivalent to negative 2n plus m. So from here, substituting the n equivalent to 1 here, you're going to have m equivalent to 2. This value, put it back into this equation, okay? So you have x equivalent to k a power 1 t power 2, or is equivalent to k a t squared. So quick quiz 1.2, true or false? Dimension analysis can give you the numerical value of a constant proportionality that may appear in algebraic expression. Okay, so what does that mean by algebraic expression? First thing first, the answer for this quick quiz is going to be false. Right, because dimensional analysis cannot give you numerical value again. By the way, talking about algebraic expression here, okay, if let's say you have a condition out, okay, A equivalent to B plus C. Okay, there is a statement given to you, minus D, let's say. Okay, this process only can be applied or done whenever the unit of B, C, and D is the same with the unit of A, right? Okay, if this is a length, this must be a kind of length, must be a kind of length, this is also must be a kind of length. Then you can have a addition or subtraction process. So the unit of 8 going to be the same. The unit of A must be the same with the unit of B, must be the same with the unit of C, must be the same with the unit of D. Then we can have additional process or subtraction process. If they are not the same, then we cannot have this kind of statement. No, not allowed if they are not the same unit, right? This is what we call it algebraic expression. Okay, but if you have, let's say you have another story of, let's say, P is equivalent to Q times R divided by Z. Okay, can we do the same thing with this one? No, because P is a product of Q times with the R over the Z. The whole bulk of this going to produce the same unit with this one. Okay, you cannot analyze P and Q only, P and R only, P and Z only, because they are not additional or subtraction. They are multiple and division. Okay, the process of multiplying Q and R and dividing them with a Z, producing the P. So you cannot have this kind of method. Okay, what you're going to do, if you want to analyze the dimensional symbol or units for the P must be equivalent to Q times with the R over the Z. You cannot have them separately like this. Okay. So example 1.2, analysis of an equation. Okay. Show that the expression V equivalent to AT, where V represents speed, A acceleration, and T an instant of time, is dimensionally correct. So this is the first purpose of using dimensional analysis just now. Okay, to check homogeneity of an equation, or to check the unit of an equation. Is it correctly or not? Or dimensionally correct or not? Right. So what we have here, given to us V equivalent to A times T. So we analyze one by one. For V, okay, is equivalent to because we want to check whether this equation dimensionally correct or not, so we're going to check one by one. For V, okay, is actually in term of SI unit is ms negative 1. In term of dimensional symbol, L T negative 1. For the AT, the dimensional analysis is going to be used here. The SI unit firstly. Can we simplify this one? Yes. So M as negative 1. So from here, we are going to replace it with dimensional symbol L T negative 1. If you see here, This one and this one is the same, right? Okay, so we can have a statement of, right, the dimensional of the V is the same, okay, to the dimension of the AT. This is a conclusion. Or you can put it in terms of statement. Therefore, left hand side, okay, the dimension of the left hand side is equivalent to the dimension of the right hand side. Done. Right. Next one. Okay, example 1.3, analysis of a power law. Alright. Suppose we are told that the acceleration A of a particle moving with a uniform speed V in a circle of radius r is proportional to the sum power of r, say r power of n, and sum power of v, say v power of m. Determine the value of n and m and write the simplest form of an equation for the acceleration. So from a statement given here, we are going to put it in terms of proportionality firstly. Okay, A is directly proportional to the R, the first statement, R power n, and V power m. Okay, this is a statement given to us. Okay, so we converted the whole bunch of a paragraph of statement here into proportionality statement. Next step, we are going to convert it into mathematical expression. So we are going to have a constant, then r power n, v power m. Right now, okay, we are going to do dimensional analysis technique. You are going to put every single thing in bracket. Okay, replace the symbol with the SI unit. You may remain the K yet because the bracket is still there. R is the radius, right? So it's actually m, okay, meter, right? The SI unit for radius is meter, power n, and then v is speed, so it's speed meter per second, okay, power m, and then bracket. Simplify this form firstly. K m, you have m here. Here is m n, and then here is m. Therefore, okay, n plus m for meter. For meter, okay, the power is n plus m, and then the second negative m. Right. Can we simplify anything else? No more. Therefore, finally, you are going to replace this with the dimensional symbol. Okay, for the acceleration, L t negative 2 equivalent to, when you open up the bracket, the k must be dropped because it's a constant and numerical value has no dimension, therefore it has no dimensional symbol. So the meter is length, okay, power of n plus m dot t negative m. So now power law analysis, right? For L, okay, you have 1 equivalent to n plus m. For the t, you have -2 equivalent to -m. Therefore, you have one settled information here, m equivalent to 2. From there, you can have n there, and is equivalent to -1, isn't it? Then finally, you are going to put the information of the power, m equivalent to 2, n equivalent to -1, into this equation, right? Then you're going to have a equivalent to k, r power n, -1, v power m, which is 2. Or simplest form it can be, okay, is k, okay, v squared over r. Alright. And we're back to example 1.1. This is actually the application to simplify things surrounding us. Okay, finding the height of a tree. If you wish to find the height of a tree but cannot measure it directly, you stand 50 meters from the tree and determine that a line of sight from the ground to the top of the tree makes an angle of 25. Here is actually degree. Okay. With the ground. How tall is the tree? So how to do this? Okay, you have from the angle here, you have adjacent side. You want to know the height of the, how tall is the tree or the height of the tree. So to the respect of this 25 degree, this is actually opposite side. So you are going to use, okay, you are going to use tangent theta, isn't it? Approximately, tangent theta is equivalent to opposite side over adjacent side. So you're going to have h, which is the unknown that we want to settle, over 50 meters. Right, so tangent, what is the angle here? 25 degree. So the h itself is 23.3. Right, meter. This is one of the application. Right. So conversion of units. Okay. This is the last part, conversion of units. Okay, when we deal with the measurement, okay, we deal with the unit. So we want to convert because let's say you are measuring a length. It could be report in meter or centimeter, or many more, such as millimeter. Okay. So we can convert the unit, the measurement, by using conversion factors. Okay, so conversion factors here. Okay, the basic one is 1 mile. This GS, yeah, US customary. 1 mile equivalent to 1609 meter, equivalent to 1.609 kilometer. Okay, or we can have another one, 1 meter. This is a common used. 1 meter equivalent to 39.37 inch, equivalent to 3.281 feet. Right, or if it is in feet, okay, we can have 1 feet equivalent to 0.3048 meter, equivalent to 30.48 centimeter. If the length is measured in terms of inch, so 1 inch equivalent to 0.0 254 meter equivalent to 2.54 centimeter exactly. Okay, and then how to convert it? Okay, example, if you have 1 inch, okay, you may written in other way, okay, 2.54 centimeter per inch, in that per 1 inch. So we have measured length of 21.5 inches and wish to convert it into centimeter. We use the conversion factor of this. Right? So like this. The conversion factors most of the time can be figured out from your calculator. Okay? So please refer to your calculator. And here is table for conversion of unit powers of 10. Okay, prefixes in simple. The one that you used to is kilo, right? Mega, giga, tera. There is exa, zeta, iota. Okay, and then if it is power negative here, deci, centi, milli is common. You now going to use to micro, nano, pico, femto, atto, zepto, yocto. Okay, and finally, okay, homework. All right, do answer this question and do discuss with me if you have any problem with it. I think that's it for the lecture. Thank you very much. See you for tutorial session.